In this video, we're going to continue topic 6.13, and we're going to look at some improper integral examples. So this first one, we have to evaluate when, sorry, that is not what was meant to happen. We have to evaluate from 1 to infinity of dx over x, which is the same thing as saying from 1 to infinity of 1 over x dx. You can look at it either way you want. So the first thing I'm going to do is I notice that I have an infinity up here, so I have to switch it to the limit notation. So we say the limit as, and I can pick any letter I really truly want. Traditionally, we put a b on the top. It goes from b to infinity of 1 to b of 1 over x dx. Because technically, I can't really have an infinite limit, so that's why we replace it with a variable. Or an infinite bound, sorry. When I integrate, I'm going to integrate just like I always do. I'm going to keep my limit out front. And I have the natural log of the absolute value of x from 1 to b. And then I have the limit as b approaches infinity, and I'm just going to go ahead and substitute in just like we always do. The natural log of the absolute value of b minus the natural log of the absolute value of 1. We know the natural log of 1 is equal to 0, so that's gone. Now I'm really ready to go ahead and just substitute that infinity in. So I have the natural log of infinity, or absolute value infinity, which is infinity, which would definitely equal infinity, which means that this one diverges. Let's look at example 2. So similar situation in example 2. I am going to, this time I'm going to go ahead and put the limit up in there. So the limit as b approaches infinity, the integral from 1 to b of e to the negative x dx. It does, in fact, look like we need to do a u substitution. You could put it out in the left-hand column. I'm going to put it out over here. So u equals, I usually do that in orange, u equals negative x, which means that du equals negative dx. So really the only thing missing, remember I showed you this shortcut, that really what's missing is this negative in front. So I'm just going to put a negative in front and not worry about the u sub and just integrate. So I now have the limit as b approaches infinity of negative, when I integrate e to the negative x, I get e to the negative x from 1 to b. So we've got the limit as b approaches infinity of negative e to the negative b minus negative e to the negative 1. All right, let's see, that's going to go positive. Let's try fixing that up a little bit before I plug my limit in there. So we've got the limit as b approaches infinity of, there was a typo on this one. It shouldn't have been, no, it'll be fine. It will be fine. So the limit as b approaches infinity of negative 1 over e to the b, right, because that's what the negative does to the exponent, plus 1 over e. All right, I'm going to go ahead and put my infinity into that right there. So we've got negative 1 over e to the infinity plus 1 over e. Remember that this is a super giant number divided, so it's a small number divided by a giant number. A small number divided by a giant number is 0 plus 1 over e. So it's 1 over e, which is a number. So therefore, this one converges.